Hello students, today we are going to see exclusively on problems on basis. Basically, you can solve these problems via two methods. So one is row echelon form and parametrization method. So row echelon form is nothing but you will compare or you will have to compare with the pivot points. Pivot points we have already studied and we know what is pivot points. Then second method is a parametrization method. Parametrization method is nothing but you are keeping in track of the free variables, and you will take some variables such as s and t to denote the you will substitute them, s and t. You will get to know with the problem again. So the choice of which method to use often depends on the personal preference or the specific requirement of the problem. So first we will solve the echelon form. So the first problem is as follows. So the first problem is find a basis and dimension for so the vectors are given. You write the vectors in the matrix form. So it is -3 6 7 -4 2 and -2 and 6. Let's apply the row transformation. Its row 2 changes to row 2 plus 4 times row 1, and row 3 changes to it's row 3 plus 3 times row 1. So you will get the matrix as 1 -3 -4, then 0 -6 -18, then 0 -2 and -6. Basically you can represent it as augmented matrix with the augmenting with the 0 ax is equal to 0 form, or you can write it directly because they are given vectors. There are no x1 and x2, so that's why I'm taking only the matrix. So let's change row 2 changes to row 2 by -6, row 3 changes to row 3 plus row 2. So the matrix will be, so I will write I'm taking some c is equal to 1 -3 -4, and row 2 will change to 0 1, it is 3, and 0 0 and 0. Now we can see it's already in the reduced form, so we can identify the pivot columns, and the pivot columns will be, it is if I take it as c1 c2 c3, then c1 and c2 are the column 1 and the column 2 are the pivot points. All right, so how to identify the basis? It's very easy. So you have to see in the question, let's go back to the question. So you have to see c1 and c2, right? So what is a c1 vector and c2 vector? It is like 1 -4 3 and -3 6 and 7. So the set of that will be the basis. So I will write the first vector and the second vector, that is 7. All right, so the question also asks for dimension. So what is dimension? So dimension is nothing but it is number of bases in the set. So what is the number of bases? They are 2, right? 2 basis is equal to 2. Easy. Let's go to the second question. So find the dimension of the vector space spanned by the vectors, and the vectors are given for that space, and find a basis. Again we will write the vectors in the matrix form. So it is 1 2 0 -4 1 0 1 3 -3 2, and 2 3 0 -2 0. All right, let's apply the row transformation method. So row 2 changes to row 2 minus row 1, then row 3 changes to row 3 minus row 2, then row 4 changes to row 4 minus 2 times row 1. If it is confusing, take one row at a time. I'm taking 3 rows at a time. So pause the video and solve for it. So the solution, I have it with me. I'm going to write them. So it's 1 -1 1 and 0 1. Okay, so this is the matrix we will get after the row transformation technique. Now let us try to change the row 4, that is row 4 changes to row 4 minus row 2. First row first row remains as it is. 0 1, it is 0 1 2 -4 2. Again second and third row also remains same. So let me write that. So the third row will be, it's 0 1, okay, it's a 0 not 1 2 2 and 0. All right, so let's change row 4. Row 4 changes to row 4 minus 2 times row 3. So I'll get the matrix as 1 1 minus 2 0 1. So first three rows again remains the same. So 0 0 1 minus 1 1. So it's 0 0 0 0, and it should be 0 and 4 and 2 minus 2. All right, the last step, r4 changes to r4 divided by 4. So 1 1 minus 2 0 1, 0 1 2 minus 4 2, 0 0 1 minus 1 1, 0 0 0 1, 1 minus 0.5. Okay, now let's identify the pivot points. So in the first number is 1, so it is x1 is there, x2 is there, then x3 is there, then x4 is there. Yes, now let us identify the bases. Same step, we'll go back to the question and see what are the bases. So basically all are there, so it is x1 x2 x3 x4, all the vectors are there in the basis. Yes, so we will write the basis as set of that. So it is the question itself, so I'm writing it here. x1 sorry 1 1 minus 2 0 minus 1, 1 2 0 minus 4 1, and 0 1 3 minus 3 2, 2 3 0 minus 2 0. So set of that, and the dimension is number of bases. So in the set, how many vectors are there? 4. So the dimension is 4. Thank you guys, stay tuned for more videos.